Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, I'm going to be dealing with 1D flow encroachments. So what I have on the screen here is my blank HEC RAS screen. We're going to start from the very beginning, and just to give you a sense of where we're going with this exercise, I've got a problem statement up here prepared, and it says, for a 450-foot encroachment on both banks, from river station 5,000 to 3,000, which river station will experience the greatest water depth? All right, so there's obviously a lot more information required, but this is the general direction of where we're going with this exercise. All right, let's go ahead and create the file first. Or the project. File, new project, navigate to the directory you want to save your project in, and then give your project a title. I'm just going to call mine exercise 16 and click OK. Okay. And with the geometric data editor open down here below, you can just click on this button or go edit geometric data. Let's go ahead and sketch out a river reach. So click on river reach, single left click to start, and then just sketch in the direction of flow. So I'm just going to give my reach a little curvature here, and then a double click to complete the reach. Okay, so I'm going to call this river A and reach 1. Next, I want to go ahead and add some cross sections to this river reach. So I'll click on the cross sections button, options, add new cross section, 0, which means I'm going to start at river station 0 at the bottom of the reach, and then just start typing in data to represent the station and elevation. I'm going to paste in some data I actually had saved. There we go. So we'll see a preview of this in just a moment. Let me just type in the overbank distance. I'm sorry, the downstream length distance, Manning's N, and then the overbank station is going to be this time at 500 and 900. Okay, if I click apply data, you now see what that cross section looks like. I'm going to add cross section at the upstream end of the reach, and then I'm going to interpolate a few intermediate cross sections based on a linear interpolation. So go options, copy current cross section. Now what I want to do here for the river station is put it at 10,000 feet. And then the other thing I want to do is go options, adjust elevation, and then increase that invert, or really all the points of the cross section, by another 20 feet, resulting in a 0.2% channel slope, and apply data. Okay, if I click close, we now have the, oops, I forgot to do something here. Cross section, I need to add 10,000 to the downstream length here. So 10,000, 10,000, 10,000, apply, and close. Okay, I think that's good. I think the graphics will update after I do the interpolation. Cross-section interpolation within a reach, and then I'm going to say we're going to have a new cross-section every 500 feet. Interpolate cross-sections and close. Great. So now we have all of our cross-sections from 0 up to 10,000 feet with all of the intermediate cross-sections that have been added. I'm going to save this geometry file by going File, Save Geometry Data. For the title, I'm just going to call this Base. It's going to be the only geometry file we use for this exercise. All right, next up, I'm going to define the flow data. So I'm going to go up to Edit, Unsteady Flow Data. And first is setting the boundary conditions at the bottom of the reach, river station 0. I'm going to click on normal depth, and then just type in the channel slope right there. All right, and then for the upstream boundary condition, I'm going to click on Flow Hydrograph. Now this time I'm actually going to define a DSS path, a file, and a path. I don't feel like I do that enough. I feel like I always kind of use the manual entry, and that's fine. It's good to know, but it's also good to know and be familiar with the DSS data input as well. That means I need to create that data. I'm going to open up DSS View, and I have DSS View open up here. I need to create a file first, so File, New. Then I'm going to navigate to the project right here. I'll just call it data.dss. Okay, so that file has been created. Now that we're in this file making edits, I'm going to come up to data entry. This is how I can create a new time series data set, is what it's called. So manual time series data set. A, I'm just going to call this the river. B, this will be for river station 10,000. C is the the flow. For E, this is the time interval. I'm actually going to change this and make it a little bit more precise. I'm going to change it to 10 minutes, and then that's fine there. I'm going to start the simulation at January 1st at the beginning of the day, beginning of the year. And the units will be in CFS, and then the type will be instantaneous value. All right. So what I have prepared in an Excel file are the data points, the values for flow rate, which is going to be released from the top of the reach. I have them saved right here. Okay, so I'm just going to Excel, highlighting the fields, Control C to copy, and then coming back to DSS view, selecting that first record in this table here, clicking paste, and then it looks like the value is pasted in just fine. So what it is base flow of 20,000 CFS. It ramps up to 100,000 CFS and then ramps back down to 20,000 CFS. I'll show you what that looks like in a plot. Here's that plot. So as I mentioned, 20,000, 100,000, back to 20,000 in a 10-minute time step over the course of 12 hours. All right, so let's go back to HEC-RAS now. We now have that DSS file and path ready to go. So I'll click this button up here to select the DSS file. And it looks like it opened up the same project I'm in, so that's perfect. Here is the path. Let's see. Okay. Can I show the plot? All right, that looks good. Just checking out all the features here. Okay. And we're good to go here with the flow hydrograph, which is our upstream boundary condition. All right, so I'm going to go File, Save Unsteady Flow Data. What I'm going to call this is 20K-100K-20K. And then, okay. Next, I'm going to run the simulation with no encroachment, and then I'll run it again with an encroachment, and then make that comparison. Save unsteady flow data, did that already, and close. Okay. So run unsteady flow analysis. It has my geometry file and my flow file already set. I'm going to call this first one just base, not for base geometry, but just base plan, meaning no encroachment. I could also call it no encroachment, but I'm going to call it base. Okay, so I can type base with just my left hand. And then let's check on the different programs to run here. No sediment yet, but then we also need to insert the starting, end, and date time. And this needs to be consistent and exactly the same as we entered for the flow data when we were over in DSS view. It's going to be the same day and then end at 12 noon. Let me just double check my data over here. So it starts right there and it goes until 12 noon. Okay, that looks correct. That looks good. I'm also going to change the computation, actually not that one, hydrograph output interval to 10 minutes. And then the detailed output interval also to 10 minutes. All right, File, save the plan, and compute. Okay, so that looks successful. I'm not going to look at the results yet because what I want to do is create a new plan. I will actually save this plan as, so I'm sort of making a copy of it. This is going to now be called encroachment. Okay, it'll be the same short ID. Okay, so I have everything else ready to go here for the changes I made to the time window as well as the output intervals. That's good. It's called encroachment now. But what we're going to do is actually add the encroachment. So go up to Options, Unsteady Encroachments. Now for target water surface rise, this is the maximum water surface rise. If we have, let's see, I guess I could look at the results for the first one real quick. Yeah, let's do that. Cross section. And change the plan to base. Just, I want to see where the water surface is. So here's the maximum at about 87, 88. And then this goes up to about almost 110. We'll say 20 feet up here. It's not going to be that high, but it wants a maximum. We can skip through the RAS mapper data. The problem statement said there's a 450-foot encroachment for the river stations spanning 5,000 down to 3,000. So I'm just going to use method 1. I think that's the simplest and all we need to do here. I'll set the method for these cross sections to 1 for the selected area. And then this will be 450 for the leftover bank. So I'll set those to 450. And then for the right over bank, it's going to be 450 feet of cross section station less than the end of the cross section. So let's open up the cross section again. 1400 is the last stationing for cross section station. So that'd be 450 less than that is 950. Let's go back here, select these fields, set the value of 950 and click OK. Also up here, minimum bank offset distance. I believe I have to set that as well. I'll just set it as a default of 0, but I could make a larger number there if I wanted to enforce some sort of buffer. All right, I think that's all I need to do here. So I'm going to click OK. And then where'd my plan data go? Here it is. I'm going to save that. And now let's run the simulation with the encroachments. So I'll click compute. Okay, that finished up. Now I'll click close. Let's go ahead and take a look at the results. So view, let's just look at some cross-section data first. I'm going to display both plans. There's the encroachment plan and then the base, which is no encroachment, and then click OK. And then what I want to do is just animate so we can step through all the time steps. I'll just do so manually here. So the water begins to rise, and I'm really not seeing any difference, but I realize I'm at River Station 10,000, which is the very top of the reach. It's about a mile from where the encroachment begins. So I'm going to just move down to where the encroachment takes place. Okay, I figured out what I was doing wrong here. I'm back. Let me back up a step. So when I'm in unsteady flow for encroachment and I click options in unsteady flow encroachments, this top drop down here has disabled all the encroachments. So the very first thing I should have done is selected base as the base model, or the base plan that I want to use to compare the results for this encroachment. Okay, with that changed, let me go ahead and click OK, and then File, save this plan, and then run compute. All right, now let's go ahead and see if those encroachments exist. So go View, let's check out some cross sections here. It opened up here at 4,000 River Station. So if I animate through, I should see the encroachments begin, because remember, they're at 450 and what was it, 950? Okay, options, animate. Let's just press the play button here. The water surface should be increasing. There's the encroachment. That looks good. So yeah, you can definitely see there's a difference in water surface elevation between here, no encroachment, and then here with the encroachment. The question is, what is the maximum depth? Or rather, what river station has the maximum depth? So I guess the question is really two-part. Which river station, and then what is the time step of that maximum depth? It may be easier to compare multiple cross sections and their depths if we go up to View and then click on Water Surface Profile. I'm going to change the symbology so it's a little bit easier to see. So go right click, Lines and Symbols, then scroll down here. Here's Water Surface Profile 1. This is a base case with no encroachment. So I'm going to just make the line thicker. And then the next item down, WS2, this is for the encroachment case. I'm going to say it's 3, none, and then let's make this, how about green? Okay, so encroachment is green, blue is base. Let's go ahead and step through the simulation here. Animate. Okay, so this is the first time step. Let me just click through here. Okay, the water surface begins to rise. Then encroachment is green, so it looks like right around 5,500 or so, 600, 6,000 is the max. And it starts coming down here. Interesting that the water surface elevation with the encroachment is actually below no encroachment down here at like River Station 3,000. But anyway, focusing on the answer here, I believe it's around 5,000, 6,000. I'm going to go right click, zoom in on this right here, and then I'm going to go back a couple time steps to what I think is the maximum. Going forward, it might be right here. So I'm going to go options, landmarks, river stationing. Okay, that didn't help too much. I believe it's right here. I believe this is 5,500. So let's take a look at 5,000, 5,500, and 6,000 in the actual data, and then we'll draw some conclusions and finish up. So I'm going to go View, Profile Summary Table. Now, right now, I'm stuck on Standard Table 1. That will probably be good enough because we can add a depth column. If I scroll down a little ways, we have, let's see, this is 6,000, 5,500, and 5,000 of River Station. I have the invert in this column. I have the water surface elevation in this column. And then I can add in a depth. So let's go with Options, Define Table. I'm going to search for depth and then scroll down. I believe it's main channel depth or something like that. Maximum channel depth. Okay, I'm going to highlight column 4 here just to override it and then double click maximum channel depth and then OK. So my maximum channel depth is now right here. And I am on time step 340, which is about 10 minutes past the peak flow. If I scroll down here, let's see, we have 6,000, and then this is 5,500, And then this right here is 5,000. So it looks like the depth is 1855 with encroachment, 1660 without encroachment, 20 with encroachment, 16.6 without encroachment, 19.33 with encroachment, 16.6 without. So I believe 20 feet right here is the river station, is the depth, maximum depth with the encroachment that occurs at river station 5500. Okay, well that's it for this exercise. Clearly there's more analysis we could do. We could add more cross sections, we could add more time periods, like a time interval less than 10 minutes, but you get the idea of where we were going with this exercise and got some exposure to building geometries and running simulations with encroachments in HEC-RAS.